Hi, my name is Muhammad Imamnan and my group member is Nimalan and Shazwan. So, we today gonna present about the silica dust. So, our agenda is physical and chemical properties, an industry that uses silica dust and health effect and control measure for silica dust. Introduction: silica dust. Silica dust is a fine particulate matter, composed of a tiny crystalline particle of silica, a commonly mineral found in a various natural material like a sand, quartz, and granite. Activities such as cutting, grinding, drilling, and sanding this material can generate airborne silica dust particle, while uh, itself is a harm in its natural state. Inhaling rehabable crystal silica RCS can pose serious health risks. Prolonged exposure to silica dust can lead to respiratory problems, include silicosis, lung cancer, and other lung disease. Therefore, implementing proper safety measure is crucial to protect workers from the harmful effect of silica dust in a various industry such as construction, mining, and manufacturing.
Hi, my name is Nimalet, and I'm going to present about physical and chemical properties of silica dust. So, the silica minerals, when pure, are colorless and transparent and have a vitreous luster. They are non-conductors of electricity and are diamagnetic. And the physical or chemical properties of silica dust are such as hardness, color, melting or boiling point, and also reactivity. The industry that use silica dust are such as miners, construction workers, farmers, and also engineers. So the example of work activities are such as breaking, crushing, grinding, or milling, or material that containing silica dust. So secondly is sandblasting or casting, paving, surfacing, or cement finishing, bricklaying, demolition, and also lastly demolition work. So as we know that construction sites are more exposed to silica dust. So the workers at the construction site are using more silica dust to build up the building, such as to use the cements and any other workers which is they are exposed to the silica dust. So the construction industry has more higher chances of workers to expose to silica dust and get some of the diseases from the silica dust. So thank you so much.
Hi, my name is Shazwan. Next, I will talk about route of entry for silica dust. Firstly is inhalation. Breathing in airborne silica dust is the primary and most significant route of entry. This occurs when individuals are exposed to activities that create fine silica dust particles such as cutting, grinding, drilling, or crushing materials like sand, stone, concrete, or glass. Operational settings like construction sites, foundries, and mining operation are particularly high risk environments for inhalation exposure to silica dust. Next is ingestion. While inhalation is the main concern, ingestion can also be potential route for entry, especially in workplace where there is a significant reason of airborne silica dust. This can occur when workers eat or drink in area where dust is present or when dust settle on food and beverage. Lastly is skin contact. Although less common, silica dust can enter the body through skin contact. This is more likely to happen in situations where workers have direct and prolonged skin exposure to silica containing materials, such as during handling through contact with contaminated surface, while the skin is less efficient route for silica entry compared to inhalation. It can still pose a risk in certain scenarios. Next, I will continue with health effect. Firstly is symptom. whether coughing, wheezing, shortness of breath, chest pain, fatigue, respiratory infection like bronchitis and pneumonia. And for the target organ, respiratory system, particularly the lungs.
So for control measure silica dust. So first, control measure is a ventilation. Use a local ventilation system that remove airborne dust before it gets to the breathing zone of the operator or surrounding employees. To successful control exposure, the exhaust system must be correctly built. This entails creating an exhaust hood that effectively capture flying dust. The user must ensure that it is continuously set up in accordance with the manufacturer requirement and remains there during its use. This includes employing the shortest flexible ducting with the fewest bands possible. To ensure optimal air exhaust, the system must be maintained. This includes servicing the dust and collector as needed. So the user must training on the proper user and the maintenance of the equipment. So for the second countermeasure, we have a personal protective equipment (PPE). So we can use the respiratory protection to provide the appropriate respiratory protection, such as N95, respirators when engineering and administrative control are not sufficient to reduce exposure acceptable level. So that's all for me. Thank you.